So in the last video we left off having learned what a C program looks like, how to compile a C program, and how to get set up and running with your C compiler. So in this video we're going to be learning about data types. So if you remember back to the last video, I said that programs written in C are generally a lot faster than programs written in Python, for example. One of the reasons for this is that C compiles to machine code, but another reason is that C is statically typed. So what I mean by statically typed is whenever I create a variable or I use any sort of data in C, I have to tell C what type of data I'm using. Whereas in Python, since it's dynamically typed, Python can automatically work out what kind of data I'm using at runtime. There's advantages and disadvantages to both, but the main one is that because C is statically typed, it has less work to do during the runtime, so it's a lot faster. But Python, since it's dynamically typed, has a lot more work to do at the runtime, so it's generally slower. So because C is statically typed, it has different keywords to create different data types. So C has 6 primitive data types. It has int, actually it has char, it has int, it has short, it has long, double, and it has float. So these are the 6 primitive data types in C. So you're probably wondering, what's the difference between each data type in C? The difference between the data types is partially to do with the way the terminal will handle them. For example, if I output an integer, the terminal will format that as a number. If I output a char, the terminal will output it as a character on the screen. One of the differences is that each of the data types are not the same size. For example, a char is only 1 byte in size, whereas a double is 8 bytes. And what that means is whenever you create a char, you allocate 1 byte of memory to store that char, and whenever you create a double, you allocate 8 bytes to store the double. So what I'm going to do is I'm going to print out the size of each of the individual data types on my computer. So there we have it here. We have a print statement that prints the size of each data type using the sizeOf function. The sizeOf function is a built-in function in C that takes the data type as the parameter. And the way we're formatting it is we're using the %lu because sizeOf doesn't return a number. It returns its own special data type that we format as a number. So if I run this, if I say gcc learn.c and I say a.out, you see we got int equals 4, short equals 2, float equals 4, double equals 8, long equals 8, char equals 1. So what this means is if I create an integer on my computer, it will allocate 4 bytes of memory to store that integer. The same as if I create a short, it will allocate 2 bytes. If I create a float, it will allocate 4, a double 8, a long 8, and a char 1. So what I'm going to do is I'm going to use Python to show you the amount of different values you can store in each of the data types. So if I print 2 to the power of 32. So the reason I'm doing 2 to the power of 32 is because an integer on my computer is 4 bytes, and 4 bytes is 32 bits because 4 times 8 is 32, because there's 8 bits in 1 byte. So if I hit enter, you'll see we get 4.2 billion. That means we can store 4.2 billion different numbers in a 32-bit integer. Don't confuse that with meaning we can store between 0 and 4.2 billion. Don't confuse that with meaning we can store between 0 and 4.2 billion numbers in an integer. That's not quite right, but I'll explain more about that in the next video. But just know that you can store 4.2 billion possible numbers in a 32-bit integer. If I do print 2 to the power of 16, we get 65,000. That means in a short, we can store 65,000 different numbers. This doesn't mean 65,000 different numbers at once. This means a number up to 65,000. And just in case you're wondering, I don't mean you can store up to 65,000 individual numbers in a short because you would use an array or something like that. A short can store one 16-bit number. That's what it can store. An int can store one 32-bit number. A float can store one 32-bit number. A double can store a 64-bit number. And a char can store an 8-bit number. That's how it works. So that's it for this video. Don't forget to like, comment, favorite, and subscribe, and I'll see you next time.